Mac and I would like to take a couple seconds to publicly acknowledge IEEE, the Institute of Electrical and Electronics Engineers, for funding our senior project.
The IEEE is the world's largest technical professional association. IEEE's membership is composed of engineers, scientists, and allied professionals. There's more information available at IEEE.org.
In this video, we're going to introduce you to two methods, the carbon paper and the vinyl sheet method, a way of getting your circuit board design onto your copper clad. But before we begin, we have to really clean these things off. So how Mac and I do it is we take our copper clad to a sink with hot soapy water and a little piece of green scrubby, and we scrub this thing down until it's clean. When you do that, you only want to scrub in one direction. Don't crosshatch it. Leave it in one direction. And after you clean it, don't touch it. If your skin oil gets on this thing, it'll keep the carbon paper and the vinyl sheet method from working. And when you go to etch it, you'll end up with a messed up circuit board. And now Mac is going to talk to you a little bit about the engineering triangle before we get into these methods.
As Wes said, this is the engineering triangle, where we have three different characteristics: fast, cheap, and accurate. But you only get to pick two. So with the carbon paper method, it's cheap and accurate, but it's not very fast. With the vinyl sheet method, it's fast and it's cheap, however it's not very accurate. But if you take a little bit more time, you're able to increase the accuracy. Alright, so for the carbon paper method, we need a few things. We need our printout of our circuit board, which I've taken the liberty of cutting down, our copper clad circuit board, a piece of carbon paper, and then a transparency of our circuit to check for errors. We'll also need blue painter's tape, an X-Acto knife, and then varying sizes of black Sharpies, as well as a sharp pencil or pen. Let's get started.
Rolling.
Alright, to begin with, we're going to take our carbon paper and place it on top of our copper clad circuit board, so that way the corners match up, and then take our printout that I've already cut down to size and actually put it on top as well. Then getting a piece of blue painter's tape, taping them down. I'm going to do it down on the side as well to make sure that that is also held down while I do this. Alright. Next is to get our sharp pen or pencil.
Right, hold on. Rolling.
And I'm very, very carefully just tracing the edge here. And then for these darker areas, we're able to just kind of cross hatch across to let us know that they are going to be filled in. Then we'll start doing this inside area as well. Again, referring back to our engineering triangle, this is very cheap and accurate, but it is not very fast. Alright, so that's enough of that method. It takes forever and a half. The next will be to actually lift up this and move the carbon paper, and then be And then to actually outline what's been traced. You probably won't be able to see it on the video because the outlining is very faint with the carbon paper, but trust me, it's there. As you can see, I am very carefully trying to trace these outlines. Part of the reason why I'm not saying anything as we're doing this. It's taking all of my concentration to stay inside the lines. And then if a mistake is made, probably like I've made right here, so we can get it and be able to scratch it out with this X-Acto knife so we can be able to redraw it. Alright, as you can see, kind of the basics of this method. Let's move on to the vinyl sheet method. Next is the vinyl sheet method. First we begin with a sheet of ORACAL 651 and then a printout of our circuit board. And what we've done is we've taken this sheet and see where it prints and then actually applied the ORACAL directly over it and actually ran it back through our printer to get our end result of our circuit design being printed onto the ORACAL. In this method, what we're doing is we're actually transferring over the toner from our laser jet printer onto our circuit board. So this also has another name, which is the toner transfer method.
Alright, here what I've done is I've taken our clean circuit board and I put it face down onto the ORACAL 651, and then I've taped it in place with some high heat tape here to hold it in place while I turn it over. I'm going to turn it over and I'm going to iron it. I've got this iron set on the polyester setting, really no higher. 275 to 300 degrees is really all we need. I'm applying a little pressure as I'm heating up the circuit board. So all we're doing is just going down here, and what's happening is the laser toner on the ORACAL 651 is transferring down onto the circuit board. Now after I get this ironed, what I'm going to do is I'm just going to let it sit until it gets down to room temperature. Now I've already pre-ironed this one so that it actually looks like it's a little faster. You actually want to iron this for about anywhere from 1 minute to 5 minutes, depending on your circuit board. But it's okay to move the iron around and get it going on there. All right, let's go ahead and let this cool off for about 5 minutes. All right, this is cool down to room temperature. It's nice. So what I'm going to do is I'm going to take this tape off. And let's see what we got. What I really like about the ORACAL is you don't have to immerse it in water or anything. You just let it go. This is well, that's not bad at all. That is not bad at all. You see here we have the ORACAL. Virtually all of the traces and everything came out. You can see right here around the edge we got some cleanup to do, but I don't see any problem with any of the traces at all in here. So what we're going to do next is we're going to take our Sharpie and we're going to take our X-Acto knife and we're going to clean it up, and then after I clean it up I'll show you a finished project. Alright, here you go. Here's the completed board. What I did was I took this Sharpie permanent marker, and you can see it's got a big chisel tip, and I used it to outline the big areas. Get the big areas marked. And then I have a little ultra fine point Sharpie permanent marker, and I use this to go over the traces. and to fill in the areas between the traces that the chisel point marker, this thing, was a little bit too big to do. For the if I found like a trace that was touching the ground plane, I got this really old rusty blade that I use, and all I did was just come in here and just scrape off where I didn't want it to be. What's really nice about this toner transfer method is this stuff is actually pretty tough, but it scrapes off and absolutely leaves no residue behind with an X-Acto knife. And we're actually going to etch this one to show you that it is a viable circuit board. It will work. After I pulled the ORACAL off and I started using my Sharpies to fill in the areas, it only took me about 5 minutes to do it. I found like 3 broken traces and repaired them. Found a couple places where traces were touching the ground plane. I didn't want that to happen, so I went in there and I cleaned that off. But this board is ready to etch, and it was made using the toner transfer method and ORACAL 651 vinyl sheet.
In this video, we introduced 2 methods to get circuit designs onto circuit boards. The first being the carbon paper method, which is cheap and accurate, however, it is not very fast. And then our next method being the vinyl sheet or toner transfer method, which is fast and cheap, however, you got to spend a little bit more time to make it accurate.
That's correct. If you look up the toner transfer method on the internet, you'll see people using glossy sheets of photo paper, glossy magazine covers, all sorts of stuff. The more you practice with this ORACAL 651, the better you're going to get at it. There's some videos on there that show people using ORACAL 651, and it looks like their images are coming out perfect. One thing we want to note for you guys is a lot of people are having a lot of trouble using the toner transfer method with Brother printers. So that's all we have for you. So for Mac, my name is Wesley. Have fun making your circuit boards, and we'll see you around campus.